Ladies and gentlemen, imagine this. You're gazing up at the night sky and suddenly a streak of light whispers across the stars, not from our solar system, but from the vast, uncharted voids between galaxies. What if that light isn't just ice and dust, but a message from another world? What if it's the key to unlocking the universe's deepest secrets? Today, we're diving into the mystery of 3I Atlas, the interstellar comet whose glowing tail has scientists and me buzzing with excitement. Is it an alien signal or just a clever trick of space ice? Buckle up, because by the end of this, you might question everything you know about our place in the cosmos. Imagine this. You're lying under a blanket of stars on a clear, crisp night, the kind where the Milky Way feels close enough to touch. And suddenly you realize that one faint streak of light isn't just another shooting star or satellite. It's something that has traveled for eons across the unimaginable emptiness between stars, carrying secrets from a world we will never visit. What if that streak isn't random cosmic debris but a silent messenger? What if its glowing tail isn't merely frozen water turning to vapor in the sun's warmth, but a deliberate flare, a beacon whispering across the void? Ladies and gentlemen, that is the thrill, the sheer electric wonder of 3I Atlas, the third confirmed interstellar visitor to grace our solar system. Discovered on July 1, 2025 by the vigilant eyes of the Atlas telescope in Chile, this object burst into awareness like a long-lost relative arriving unannounced at the family door, familiar in shape, yet utterly alien in origin. Let me take you back to that moment of discovery. Astronomers were scanning the night sky, as they do every night, hunting for asteroids that might one day threaten Earth, when a tiny moving point of light caught their attention. It wasn't orbiting the sun in the lazy ellipse of our homegrown comets. No, its path was hyperbolic, screaming through space at speeds far too great for the sun's gravity to hold it forever, over 137,000 miles per hour, when first spotted, accelerating to around 153,000 as it swung closer. That velocity at infinity, the excess speed it carries from beyond our system, clocks in at about 57 kilometers per second. In cosmic terms, that's not drifting, that's hurtling with purpose, as if flung from another star's cradle billions of years ago. Pre-discovery images pulled from archives stretched its story back to mid-June, confirming what the Minor Planet Center soon declared: this is no local wanderer. It's 3I Atlas C for Comet, 3I for the third interstellar object ever confirmed, following Oumuamua and Borisov, and right from the start it behaved differently. Now here's where the real excitement begins to build, the part that makes your pulse quicken and keeps you leaning forward in your seat. Most comets slumber in the deep freeze until they draw near the sun, their ice is sublimating only when heat awakens them. But 3I Atlas, it started showing activity. A glowing coma, that fuzzy envelope of gas and dust far earlier than expected, already active at distances around 4 to 5 astronomical units from the sun, way out beyond Jupiter's orbit. And that tail, oh, that magnificent glowing tail began to shine with an intensity and persistence that has astronomers poring over spectra late into the night. Spectroscopic readings reveal the usual suspects: water ice, carbon dioxide, perhaps some exotic primordial compounds forged in the cold nurseries of another stellar system. Yet the glow activated sooner, brighter in places, with color shifting in ways that hint at unusual chemistry. Is this just the stubborn resilience of ancient ices preserved for eons in the interstellar void? Or is there something more, something modulated, something patterned? Think about it. In the quiet vastness between stars, where temperatures plunge to near absolute zero and radiation is a whisper, most objects go dormant. But 3I Atlas refused to sleep. Its coma-expanded dust streamed outward at velocities from millimeters to meters per second, and mass loss rates climbed to kilograms per second in bursts. Photometry from observatories around the world, Palomar, Apache Point, Katamia, showed color indices that paint a picture of a reddish, dusty surface, yet with blues emerging as it neared the sun, bluer than expected. And then there are those jets, those sunward features. Even an anti-tail illusion that some observers mistook for something stranger. The tail itself stretched dramatically after perihelion on October 29, 2025, when it grazed just 1.36 astronomical units from the Sun between Earth and Mars, reaching lengths visible across degrees of sky, with ion tails sharp and structured, dust tails fanning out in graceful curves pushed by solar wind. This isn't just data on a screen, it's a story unfolding in real time. A visitor older than our own Sun telling tales of the galaxy's youth. Estimates place its age potentially between 3 and 14 billion years, possibly as much as 7 billion or more, if it hails from the Milky Way's thick disk, that ancient population of stars born when the universe was still young and violent. Imagine this tiny nucleus, perhaps a kilometer or two across Hubble, pegged at between 440 meters and 5.6 kilometers, has drifted through the cosmic dark for longer than Earth has existed. Witnessing supernovae, the births of generations of stars, perhaps even the faint echoes of the Big Bang's afterglow in its pristine materials. Every grain of dust it sheds, every molecule it releases, is a fossil from another epoch, a time capsule hurled across light years by gravitational chaos in some distant system. And yet, amid all this grandeur, the questions linger like shadows at dusk. Why did it wake so early? Why does its activity seem to pulse in ways that defy simple models of sublimation? Some have whispered about non-gravitational accelerations, about brightness surges, about spectroscopic oddities that challenge expectations. In my own discussions on News Nation, on NBC, I've emphasized the need for caution. The data leans overwhelmingly toward a natural comet, an icy body from the Oort-like cloud of another star, perhaps ejected in a close stellar encounter long ago. But science thrives on the edge of the unknown. We must monitor closely, scan with radio telescopes for any artificial patterns, analyze every photon for hidden structure, because if even one anomaly holds up, if that tail's glow carries a signal, if its path betrays subtle corrections, then we stand at the threshold of something profound. Feel that shiver. That's the emotion of discovery, the awe that has driven humanity since we first looked up and wondered. 3I, Atlas, isn't just a rock of ice, it's a reminder that the universe is alive with motion, with stories we are only beginning to read, as it continues its journey outward now, fading but forever changed by its brush with our star. It leaves us richer in knowledge, hungrier for more. And in that hunger lies the true magic, the drive to build better telescopes, to launch probes that might one day chase such visitors, to dream of the day we decode whatever message, natural or otherwise, this wanderer has brought us. The glow of its tail still echoes in our instruments, a light that traveled billions of years to reach our eyes, urging us to keep watching, keep questioning, keep reaching for the stars. Imagine this as 3I, Atlas streaks through our solar system like a bullet fired. From the depths of the galaxy, its path isn't the gentle curve of a homegrown comet lazily circling the sun. It's a razor-straight hyperbolic trajectory, a one-way ticket screaming past our star at blistering speeds that no planet or moon could ever dream of matching. This isn't drifting, this is defiance of gravity itself. When astronomers first traced its incoming arc, the numbers leaped out, an eccentricity greater than 6, the highest ever recorded for an interstellar object, meaning its path bends only slightly under the sun's pull before flinging it back into the interstellar void forever. At discovery, it was already hurtling at around 221,000 kilometers per hour, relative to the sun faster than any natural object we've seen ejected from our own system. Picture it. This wanderer doesn't loop. It slices straight through, brushing past Jupiter's orbit, dipping inside Mars' path at perihelion on October 29, 2025, at just 1.36 astronomical units from the sun, then accelerating outward again, unbound, unstoppable, carrying the momentum of whatever cataclysmic event hurled it from its birth star billions of years ago. That hyperbolic highway tells a profound story of origin. Most comets in our backyard follow elliptical orbits, trapped in the gravitational embrace of the sun since the solar system's chaotic birth 4.6 billion years ago. But 3I Atlas, its excess velocity, the hyperbolic excess, is about 58 kilometers per second at infinity, proof it was kicked out of another star system with ferocious energy, perhaps during a close stellar flyby. A planetary migration upheaval, or the violent scattering that shapes young planetary disks. Tracing backward, its incoming direction points roughly towards Sagittarius, near the galactic center, but more intriguingly, models suggest it hails from the Milky Way's thick disk, that ancient, puffed-up layer of older, metal-poor stars formed during the galaxy's turbulent youth. This isn't a thin disk youngster like our Sun. This is a relic from cosmic noon, when star formation raged across the universe 9 to 13 billion years ago. Feel the weight of that timeline. While our solar system was still a swirling disk of gas and dust coalescing into planets, this object was already adrift, a frozen survivor of galaxies in their prime. And then comes the shiver-inducing realization of its age. Estimates converge on something staggering, between 7.6 and 14 billion years old, potentially older than the 4.6 billion year solar system itself. Independent analysts agree, one pegging it at 3 to 11 billion, another narrowing to 7.6 to 14 with 68% confidence based on thick disk stellar population. Imagine what this tiny nucleus, perhaps 1 to a few kilometers across, has witnessed. It has floated through the interstellar medium for eons longer than Earth, has spun on its axis, bombarded by cosmic rays bathed in the faint glow of ancient supernovae, perhaps passing through molecular clouds where new stars were igniting. Its surface ices, if primordial, could preserve chemistry from the galaxy's earliest epochs, molecules forged in the cooling aftermath of the Big Bang's echoes, untouched by the repeated heating cycles our local comets endure. For every spectrum we capture, every photon from its coma, is like opening a time capsule sealed before our sun even flickered to life. The emotion hits hard here. We're not just observing an object, we're touching the deep history of the Milky Way, a piece of the cosmos that predates our entire planetary story. Yet, amid this ancient serenity, the path itself raises tantalizing whispers of anomaly. Its trajectory aligns eerily close to the ecliptic plane within 5 degrees, something statistically rare, with probabilities as low as 0.2% for a random interstellar arrival. It grazed near multiple planets, close approaches to Mars, a swing past Venus and Jupiter regions, almost as if threading a needle through our system's architecture. Some note retrograde motion. Others point to subtle non-gravitational accelerations that hint at outgassing forces beyond simple ice sublimation. Is it just gravitational perturbations from unseen encounters long ago? Or does the path carry the faint imprint of something more deliberate, a nudge from a distant encounter that set it on this improbable course? Science demands we lean toward the natural explanation, a chaotic ejection from a distant exoplanetary system, flowing into the void by gravitational chaos. But the alignment, the precision timing that brought it visible to our telescope, exactly when humanity has the tools to study it, this stirs something primal, a sense that the universe is arranging these encounters for us to notice, to wonder, to feel small yet profoundly connected as it hurtles onward now, fading into the outer darkness after its solar brush. That hyperbolic path becomes a bridge across time and space. It reminds us that the galaxy is not static, it's a churning ocean of matter where worlds are born, shattered, and their remnants scattered like seeds on cosmic winds. 3i, Atlas didn't choose this route. It was launched by forces we can't only model from afar, but in doing so, it has delivered a gift, prestige, material from another stellar cradle, a glimpse into chemistry we can't replicate in labs, a story written in light and dust that spans epochs. The awe builds with every detail. This isn't just a fast-moving rock, it's evidence that the universe is vast, violent, and full of travelers like us, silent, enduring, carrying memories of places we'll never see. And in tracing its arc, we feel the pull of curiosity that has defined humanity since we first point. Eyes to the sky, what else is out there, hurtling toward us or away, waiting to share its secrets. The path of 3I, Atlas doesn't end with departure, it ignites the next chapter of our quest, urging us to build bigger telescopes, launch fast probes, dream bolder dreams about chasing these interstellar ghosts across the void. Imagine this right in the heart of the debate that has gripped astronomers and dreamers alike stands the most provocative possibility of all. What if the glowing tail of 3I, Atlas, isn't just the natural sparkle of sublimating ices catching sunlight, but something deliberately crafted, a modulated pulse carrying information across the stars? Feel that rush of adrenaline, that mix of skepticism and wild hope that surges when we confront the unknown. We've chased signals from the cosmos for decades through SETI programs, listening for narrowband whispers that stand out against the roar of natural radio noise. And here comes this interstellar visitor, active far from the sun, with a tail that flares and dims in patterns some have dared to call suspicious. The elephant in the room, the question that keeps everyone up at night. Is this tail merely space ice doing what ice does, or could it be the faint echo of an alien signal? Let's ground ourselves in the facts first, because true wonder builds on solid ground. Comets glow because solar ultraviolet radiation heats their volatile ice as water, carbon dioxide, methane, turning them straight from solid to gas in a process called sublimation, creating that beautiful coma and streaming tail pushed back by solar radiation pressure and the solar wind. For 3I Atlas, the tail emerged unusually early, at distances where most comets remain dark and inert, and its brightness surged with exotic spectral lines hinting at compounds rarely seen in our local population. Yet every major observatory from Hubble to ground-based giants has captured data showing classic cometary behavior. Dust grains reflecting sunlight in reddish hues, gas emissions matching primordial chemistry, ion tails straightening under magnetic fields of the solar wind. No artificial modulation, no repeating codes, no laser-like coherence that screams technology. Breakthrough Listen, the most powerful SETI effort on Earth, turned the Green Bank telescope, an Allen telescope array, toward it during key Windows hours of listening across gigahertz bands, sifting millions of candidates with ruthless filtering for terrestrial interference, and the result? Silence. Absolute cosmic quiet on any narrowband technosignature, limits set so tight they could detect a cell phone's power output from hundreds of millions of kilometers away, and nothing artificial localized to the object emerged. Other arrays, like Meerkat in South Africa, echoed the same verdict: no engineered radio emission, no pulsed beacon riding that glowing tail. But science doesn't slam the door shut. It leaves it cracked just enough for curiosity to peek through. Remember Oumuamua, our first interstellar guest? Its cigar shape, tumbling motion, and subtle non-gravitational push without visible outgassing sparked fierce debate. Avi Loeb argued it could be a light sail fragment from an alien probe. 3I Atlas is rounder, easier, more classically cometary, yet its early activation and occasional brightness flares invite similar whispers. Some fringe speculations point to pulsed emissions resembling signals, or alignments with old mysteries like the 1977 WOW signal, though probabilities remain vanishingly small. Radio telescopes have been quietly aimed its way, not just for natural plasma emissions from the coma, but to rule out or dream of something more. In my own reflections on these visitors, I've stressed caution. Extraordinary claims demand extraordinary evidence, and right now the scales tip heavily toward nature. Yet the possibility lingers like a distant star, faint, tantalizing, refusing to vanish entirely. What if advanced civilizations send probes disguised as natural objects, von Neumann machines self-replicating across the galaxy, seeding knowledge or watching quietly? Such ideas aren't fantasy. They're extensions of physics we already explore: self-replicating nanotechnology, beamed propulsion, cryogenic preservation for eons-long journeys. Now shift gears with me into the deeper physics, where the real chills set in. Quantum mechanics offers pathways that make these speculations feel less like science fiction and more like tomorrow's frontier. Consider entanglement. Particles linked instantaneously across vast distances, defying the speed of light, in correlation if not information transfer. Could the tail's persistent glow, its odd color shifts even at great distances, hint at quantum effects amplified by some unknown mechanism? In string theory, which I helped pioneer with field theory formulations, extra dimensions curl up at tiny scales, yet they might allow shortcuts, vibrational modes that propagate information in ways classical physics forbids. A Type 3 civilization on the Kardashev scale, mastering the energy of entire galaxies, could harness black holes for power, engineer wormholes for transit, or send scouts that exploit these hidden layers of reality. What if 3i Atlas's tail is a quantum flare, a side effect of entanglement bridging to a probe's origin system, or even a deliberate beacon stabilized by quantum coherence against decoherence in the interstellar void? These aren't wild leaps. They're logical extensions of equations we solve today in labs, pushing toward quantum supremacy where computers simulate realities we once thought impossible. The emotion here is profound, all mixed with humility. If natural 3i Atlas is a pristine relic teaching us about stellar formation across cosmic time, but if artificial, if that glow hides a message or a mechanism, then the galaxy isn't empty. It's alive with intention, with minds that have already crossed the abyssal distances we struggle to imagine. We've scanned with the best tools humanity has built, found no smoking gun of technology, yet the anomalies, the early wake-up, the path's eerie precision, the age that predates our world keep the conversation burning. SETI continues, listening not just for this visitor, but for the chorus it might represent. Feel that pull in your chest. The universe isn't indifferent. It's inviting us to question, to probe deeper, to evolve our understanding until the line between impossible and inevitable blurs. This isn't the end of the mystery, it's fuel for the next generation of dreamers and scientists, reminding us that every photon from that distant tail carries the potential to rewrite our story in the stars. Imagine this, here we stand at the crossroads of one of the most profound moments in human history, with 3i Atlas having brushed past our sun, swung through the inner solar system, and now racing outward once more into the eternal dark. Yet it has left us forever changed, not just with data points on screens, but with a visceral reminder that we are part of something far grander, far more interconnected than our daily lives suggest. If this interstellar wanderer is purely natural, and the overwhelming weight of evidence from spectra, trajectories, and SETI silence points firmly in that direction, then it serves as the ultimate time capsule, a frozen library of chemistry from the galaxy's distant past, teaching us about the raw ingredients that seed stars and planets across the cosmos. Its pristine ices, rich in volatiles that have survived billions of years without the repeated baking of a close stellar passage, offer clues to how organic molecules form in the cold voids between systems, perhaps even hinting at the prebiotic building blocks that could spark life wherever conditions allow. We learn from its dust grains, its gas outbursts, its unusual nickel signatures accumulated over eons of cosmic ray bombardment and interstellar garbage collection. As I've described it, materials that tell stories of supernovae explosions, molecular cloud collapses, and the slow churn of galactic evolution long before our sun ignited. But pause and let that sink in deeper. Even if natural, 3i Atlas accelerates our own trajectory as a species. It forces us to confront the Fermi paradox head-on, where is everybody, and pushes humanity to respond with action rather than passive wonder. Think of the practical fire it ignites. Elon Musk and SpaceX dream of starship fleets chasing such objects, intercepting them for samples, mining their volatiles for future outposts, or simply studying them up close with robotic probes launched on high-energy trajectories. NASA and international observatories ramp up monitoring networks, quantum computers simulate the object's path, composition at unprecedented fidelity, and global collaborations form to decode every last photon it emitted during its dramatic perihelion flare. This isn't abstract, it's the spark that could propel us toward becoming a multiplanetary, then interstellar civilization. In my books like The Future of Humanity, I outline how such wake-up calls drive us to harness fusion antimatter drives, laser sales technologies that turn science fiction into engineering blueprints. Three-Eye Atlas whispers the galaxy is full of travelers, and if we want to join them, we must evolve beyond our cradle, build the tools to reach out, and prepare for whatever comes next, be it benign discovery or the rare, slim chance of something more deliberate. Now feel the deeper tremor, the one that stirs not just intellect, but soul. What if? Against all current probability, this visitor carries even a whisper of artificial intent. The door isn't bolted shut. Anomalies persist in the public discourse, from brightness surges to path precisions that some model as statistically improbable, though most astronomers chalk them to natural chaos. In interviews I've given on NewsNation, NBC, Newsmax, I've emphasized that data leans natural, attributing oddities like high nickel content or early activity to its extraordinary age, perhaps 7 billion years or more, allowing accumulation of exotic elements over cosmic time. Yet I've also noted that the final chapter remains unwritten. A non-nil possibility lingers, because science is humble before the unknown. If artificial, if this were a von Neumann probe, a relic scout, or a message in icy form, then the implications cascade like a supernova. The galaxy teems with intelligence that has already mastered the vast distances we struggle to cross, perhaps watching seeding, or simply archiving the rise of civilizations like ours. It would shatter isolation, ignite philosophical revolutions about our place, and demand we accelerate SETI, quantum decryption, interstellar, engineering to answer back. The emotion surges here, hope intertwined with humility, excitement laced with responsibility. Whether natural time capsule or hypothetical beacon, Three-Eye Atlas is our cosmic wake-up call, a mirror reflecting how small, yet how capable we are. It urges us to dream bigger, colonize Mars, not as escape, but as stepping stone, build telescopes that peer into other systems, develop AI and quantum systems to sift signals from noise across light years. Humanity stands at this threshold, no longer just observers, but potential participants in the grand galactic conversation. The visitor has departed, but its legacy burns bright, urging us to reach higher, question deeper, unite in pursuit of truths that transcend borders and generations. This isn't mere astronomy, it's a call to awaken our species' latent potential, to transform awe into action, wonder into wisdom. So as we wrap up this journey through the enigma of Three-Eye Atlas, let's bring it all together with the clarity and wonder that this cosmic visitor deserves. We started with a simple streak of light in the sky and ended up holding a mirror to our own place in the universe. Whether its glowing tail was nothing more exotic than ancient ices awakening under a foreign sun, or whether some faint, tantalizing anomaly keeps the door cracked open to wilder possibilities, one truth stands unshakable: Three-Eye Atlas has changed the conversation forever. If it is purely natural and the data, the spectra, the trajectories, the silence for every SETI sweep all point powerfully in that direction, then this interstellar comet is one of the most precious gifts the galaxy has ever handed us. A pristine relic older than our own sun, carrying chemistry from epochs we can barely comprehend. It has taught us that the ingredients of planets and perhaps even life are scattered far and wide across the Milky Way. It has shown us how violent and dynamic the cosmos truly is, stars flinging worlds apart, gravitational chaos seeding, wanderers like this one into the void, and now one of them has passed close enough for humanity to reach out with our telescopes and touch its story. And even in its most ordinary explanation, Three-Eye Atlas is anything but ordinary in what it demands of us. It is a wake-up call wrapped in ice and dust. It reminds us that we live in an interstellar neighborhood, that visitors arrive unannounced, that the galaxy is not a static painting, but a living, breathing ocean of motion and matter. It pushes us to dream bigger, to build the next generation of space telescopes, to perfect quantum computers that can decode the faintest signals, to launch fleets capable of intercepting future wanderers, to turn science fiction into engineering reality. It tells us that the future of humanity is not confined to this pale blue dot. It is written in the trajectories of objects like Three-Eye Atlas, urging us to become a species that chases the stars instead of merely watching them pass by. And if the anomalies someday prove to hide something more, if that tale ever reveals a pattern or a purpose we missed the first time, then the implications become almost too vast to hold. It would mean we are not alone, that minds far older and wiser have already crossed the abyssal distances we struggle to imagine, that the silence we call the Fermi paradox might simply be the sound of patience. Either way, natural time capsule or hypothetical beacon 3ein. Atlas has done something extraordinary. It has made us feel small and yet infinitely capable at the same time. It has reminded us that curiosity is our greatest engine, that wonder is the fuel of progress, and that every time we look up, the universe is looking back, waiting for us to ask the next question. So here we are at the end of this chapter, but only at the beginning of what comes next. The comet has faded into the outer darkness, but its light still echoes in our minds, in our instruments, in our dreams. Go outside tonight if you can. Look up. Find that quiet corner of the sky where it once streaked through and feel it, the awe, the humility, the electric thrill that we are part of something immense and beautiful and still unfolding. Thank you from the bottom of my heart for joining me in this adventure. Thank you for your curiosity, for staying with me through every twist and turn, for daring to wonder alongside me about what might really be out there. You are the reason these stories matter, and together we keep pushing the edge of what we believe is possible. Keep looking up. Keep asking the big questions. And until the next cosmic surprise arrives, keep dreaming big. Thank you and good night.